All right, so I'm going to go ahead and do a couple examples from the 8.3 section, the last part about compounding continuously. Now, the compounding continuously is the formula A equals P e to the RT. And this is one of the application uses to the natural base E. Now remember that E equals 2.71 approximately. All right, so if I am in Desmos and I type E, it automatically gives me that number that it is approximating. Right? Nothing special, just type the letter E on your keyboard. Okay, so this formula is for compounding continuously. Okay, so let's read our problem and set it up. Samuel is going to invest in an account paying an interest rate of. Okay, so that means that the interest rate is 5%, which we will write as a decimal, compounded continuously. That means that we're going to use this formula. How much would Samuel need to invest to the nearest dollar for the value of the account to reach $77,000 in 9 years? So that means that the T is 9 years, okay? And the account, that's the amount, okay? P is the amount you start with, okay? A is the amount you end with. So P is called principal. That's how much you start with. A is how much you end with. So let's plug in the information that we know. Okay, so A equals P-E-R-T. So we have 77,000 equals, I don't know my principal, my rate is times 9. Okay, now I want to know what P equals. So can we divide both sides of the equation by this amount? We can. All right, now I like to write my P on the left side. Divided by E, that's 0.45. Okay, so that's why I have Desmos open over here. I'm just going to type in as my calculator E power. Now you can write the 0.45 or you can actually write the multiplication. Okay, now it says to the nearest dollar. Okay, so let's round to the nearest dollar. I believe that would be 49097 because we're rounding down. Okay. 49097. Yay! Okay. All right, let's clear this. Let's do one more. Okay. Julian is going to invest in an account paying an interest rate of 1.9. Okay, so A equals P-E-R-T. So here's my R. So R equals 0.019. Time equals 11 years. Okay, and the amount is 10600, and P is unknown. Okay, so let's plug this in. 0.019 times 11. Okay, so I'm going to divide both sides by this amount. All right.
Echo, show me the sunrise.
Okay, so let's see. 10600.
Yes.
11 19. Okay, nearest $10, so that actually seems pretty reasonable. So 8600. All right. All right, so I'm going to do a different problem here. And let's zoom in just a bit. Okay, so we have Carson invested $2,700 in an account paying an interest rate of compounded continuously, assuming no deposits or withdrawals are made. How much money to the nearest cent would be in the account after 5 years? So I'm going to start with my compounding continuously formula. Okay. And I'm going to start plugging in what I know. So the P is how much money I start with. All right, so our P value is how much money I start with. So that's 2,700. Our rate is 0.016. And our time is 5 years. So let's go ahead and, okay, let's type it in. The principal is 2,700. E power and parentheses 0.016 times 5. Okay, so it says to the nearest cent. So we need 2924.88 because we are rounding. All right. Nice job. I hope that was helpful.